All right, so this is a topic that's unique to trigonometry and stuff like that. You need to understand the fact that at the moment you're used to this whole idea that one complete circle is listed as 360 degrees. Okay? And you're perfectly comfortable with that, it's not a problem. Okay? So if I said to you, I want a third of a circle, one way to work it out is to say 1/3 times by 360. Oops. Okay? If I want, so by that logic then, what's 17 degrees? 17 degrees is 17 360ths of a circle. Okay? You need to get that in your head really, really clearly, that that's what's going on. Now, why is that really, really useful? Well, for instance, if I said to you, here is a sector of a circle, I'm going to tell you that that's 40 degrees. Okay, I'm going to tell you that that's 8, and I want to know how long that is. Okay? What you would have to do, and you should know how to do this already, I'm going to do it for you, so don't panic. Okay? But what you should be able to do is to say, right, well, the area of the whole circle, if I had a whole circle with radius 8, its circumference would be pi times the diameter. You know that. Okay? Or 2 times pi times r, if you prefer. Okay, so in this case, the circumference would be 16 pi. Now, pi is 3.14159, blah, 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 and I'm perfectly confident that you can calculate that, but I'm not going to do that. I'm just going to call it 16 lots of pi. So if I wanted just this little bit of my circle, and that's all I wanted, then I could say, well, I want 40 360ths of that. So this length would become 16 pi times by 40 divided by 360. And that's how I find what's called an arc length. Equally, if I say, well, what's the area of this bit in here? Then all I'd say was, well, if I had a whole circle, that would be, area of a circle is, I'll move my finger this way, there we go, that's better. I could say the area of a circle is pi r squared. Okay, we know that the radius is 8, don't we? So the area must be 64 pi. Since 8 squared is 64, and 64 times pi is 64 pi. Okay, hopefully that makes sense. Okay, so now if I want the area of my little chunky bit here, what am I going to do? Well, what I'm going to do is go 64 pi, the whole circle, divided by 360 times by 40. And that's how I find the area of a sector. It all makes sense. Because all this is a chunk of a circle. It's a bit of a circle. If it was half a circle, I'd times by half. Yeah? And that's how that works. Okay, so you get that idea. Now, in order to make life easier, you need to understand the fact that angles in circles are largely come about because of the Babylonians in about 4000 BC. Because what they did was they counted in 60s, which is why we have a 60 seconds and a 60 minutes, and we have 360 degrees in a circle. Yes, it all comes from that idea that they understood heavens and they understood the stars, and they counted in 60s. So where we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, they would go blah, 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 59, that's a 60th. Okay? Now, a number of years ago, mathematicians and engineers, so let's do engineers first of all. Anybody going into engineering? Okay? Well, then you should already know that one circle, one complete circle, is actually classed as 100 radians. Yeah? So, in other words, if you want the whole circle, they want 100% of the circle. Yes? So they call gradients. Now, mathematicians use something called radian measure. And it's quite simple. You know you called 360 degrees a whole circle? Well, a mathematician says a whole circle is 2 pi radians. Okay? 2 pi radians. That's what it's just decided. That's the way it is. We've decided that a whole circle is 2 pi. And I'll show you why. Let's go back to my earlier question. Did you have an exact answer for me? We didn't, did we? No. What we had was 64 pi divided by 360 times by 40. The problem is pi is 3.14159 blah, 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 blah. So we're always going to have an approximate, aren't we? We're going to have a almost there. Okay? And because pi is an undefined number in terms of, it just keeps going. Okay? So, this is what we're going to do. We're going to do exactly the same question again, but instead of 40 degrees, I'm going to write down 1 radian. Okay? So, here's the question. Still 8. Okay? That's now 1 rad. Okay? Can I put it down? Thank you very much. I really appreciate that. Well done. So, there we go. That's better. If you don't see what I'm talking about, and I'm clearly writing, say something. Okay? So, whole circle is 2 pi. This is 1 radian. In other words, what fraction of the circle have I just given you? No. 1 radian is... What fraction of the circle have I given you? Okay, let's recap. If I gave you this bit and I told you that was 25 degrees, what fraction of the circle have I just given you? 25 out of 360. Does that make sense?
Yeah.
Right? So 25 bits of a whole circle. Right? So what fraction of a circle have I just given you? 1 over 2 pi. Thank you very much. Okay? So if I, for instance, gave you this one, and I said this was 1.6 radians, then what fraction of a circle have I now given you? 1.6 over 2 pi. And you might think to yourself, man, he's making this more complicated. Trust me, I'm not. Okay? Because now, let's look at what happens when I want to find out the arc length. Okay? The procedure is going to be the same. Circumference is 2 pi. So, right, 2 pi times by the radius, isn't it? Or pi times the diameter. Yeah? The radius is still 8, so that's still going to be 16, isn't it? So that's now 16 pi, and that would be the circumference of the whole circle. But I don't want the whole circle, I want 1 radian's worth. So what am I going to do? I'm going to go, right, well, 1 radian is 2 pi of the whole thing. So I can now say, in exactly the same way as last time, I times it by the angle I had and divided by 360. I'm going to go 16 pi times by the angle I have, 1, because it's 1 radian, divided by 2 pi. And guess what happens? The pi's cancel each other out. Because pi divided by pi is 1. So that means the pi's have cancelled each other out. The 2 cancels with the 16 becomes 8. And that's my answer. So by deciding to use 2 pi, bearing in mind everything we do with a circle has got pi in there somewhere, then suddenly the pi's disappear. Then it makes my life a lot easier. I've now got an exact answer. Now, even if I'd used 1.6, look, I'd have still had 16 pi divided by 2 pi times by 1.6. If I chose to do that, wouldn't I? And again, the pi's will still cancel. That will still cancel and turn that into 8. And all I've got is 8 lots of 1.6, which is easy to do and gives me an exact answer. Now, the same will apply for the area. If I want the area of my little thingy here, then all I'm going to do is say, well, the area of a circle is pi r squared, which in our context gives us 64 pi. So, if I want 2 pi of that, then all I've got to do is go 64 pi. There was my dyslexia kicking in there. 64 pi divided by 2 pi times by 1. Or in other words, 32. And that becomes much easier. Now, I know I went through that fast, but to be fair, I did video it, and you can watch it as many times as you like.